Let's continue talking about regular languages and regular operations. Specifically, we're going to talk about concatenation, star, and complement. We're not going to do the proofs for concatenation and star just yet. These are made much easier when we have the machinery for NFAs, for non-deterministic finite automata. And for complement, some of you have a proof of closure by complement as a homework assignment, so I won't do that. But we can talk about that later. Right now, let's just look at those operations and what they mean. These might not be as familiar to you as intersection and union, so it would be helpful to see what they actually look like. Okay, so first, let's talk about concatenation. So, as some of you might remember from programming, when we concatenate one string with another string, we basically mean we're attaching a string to the end of another string. Okay, that's what it meant in programming languages. So let's start off with two languages. I'm going to call them A and B. I know, very creative, right? Languages A and B. And A is just going to be the set of strings AA and BB. Okay? And B is going to be the set of strings AAA and BBB. Okay, and here I'm assuming sigma is AB. Okay? To be formal. All right, so what we want to know is what is the language AB? Okay, what is this language? Books also write it A little circle B. Okay, these are typically considered the same thing. All right, so this means we're going to take a string from A, and then we're going to add onto the end of it a string from B. That's how we would form a concatenation AB. More specifically, the language AB is every combination that takes a string from A and concatenates onto the end of it a string from B. Okay, so let's start with a string from A. We have AA, and let's stick on the end of it a string from B. Let's add on the string AAA. Okay, that took something from A and something from B. So that's one of them. Let's take AA again from A, and let's add on BBB. Okay, let's take the other string from A, let's take BB, and the first string from B, AAA, and then let's take again BB and the other string from B, BBB. All right, so for this pair of languages, this is the complete language AB. Okay, if either one of the two languages were infinite, then AB would also be infinite. Okay, luckily here we picked two finite languages, so we can actually enumerate all of the strings. Okay, so that's AB. So we can ask ourselves some questions like, is the string, let's take the string B, 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 AA. Is this string, oops. There we go. Let me get rid of this. Okay. Is this string an element of the language AB? Okay, well we can look at our list and see that it's not listed there, or we can ask, how would we have constructed this string? Well, this part of the string is an element of B, and this part of the string is an element of A. So we see here that this string is actually an element of the language BA, but it is not an element of the language AB. So the important thing to note here is that when concatenating languages, the order matters. Which string we took from which language in which order matters. Okay? So that's concatenation. Let's also look at star. So let's define a new language. It's going to be another finite language. It's a little easier. Let's take C, language C, to be the set of strings A, B, and BA. Okay, and now we're looking for C star, sometimes called Kleene star. Okay, so what this means is, it means 0 or more strings from language C. Okay, so if I take 0, I'm going to end up with epsilon. Or I could take 1, which would give me AB and BA. Or I could take 2, this would give me AB, 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 BA, 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 BAAB. Or I could take 3, AB, 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 BA, and you can see this is going to get really long really quick. And this one is going to be an infinite language because I can always take any string and add another of these kind of like root strings onto the end to make a new string. Okay? So that's going to be C star. So it's kind of like concatenation, only I'm only doing it on one language, and I can repeatedly concatenate. I can continue to concatenate. Whereas we saw with concatenation, I had to take one string from the first language, one string from the second language, and that was it. I was done. No more. Okay? So that's star. Let's also look at complement. And to do this, we can actually look at all the language we've talked about so far. So let's take A. Again, A was AA, BB. Okay, so what's a complement? It's going to be anything in the universe. So here, what sigma is really important. Okay, so sigma is AB, which means my universe is sigma star. Any string, all strings over the language AB. That's my universe. Okay, so a complement is any string in the universe that's not an A. Okay, so A doesn't contain the empty string, so that one's there. It doesn't contain the single character A or the single character B. It doesn't contain AB. It doesn't contain BA. Okay, and I can keep going. It doesn't contain AAA. All right. Let's actually take the complement of AB. So this formed a language, right? We had the concatenation of AB. And then if I take the complement of the concatenation, it means anything that wasn't in that concatenation. So let's try to remember what was in B. It had 3 A's or 3 B's. So things that are in this language, if I have 4 A's, okay, I can't be in the concatenation of AB because AB only gave me 5 A's, right? That was one way, that was one string in AB. So I can't get 4. There's no way to do that. It can't have 4 B's. Okay, so it's in the complement because it wasn't in the concatenation. I said if we had AAABB, that this was formed by BA, but not AB, so that's going to be in the complement. Some mixed strings, like this, okay? Or many other things like A, things like B. Okay, so you can see if the original language, such as AB, is small, then the complement is going to be very large. We see this with A complement or AB complement, okay? All right. So we also had the language C, and so the language C was ABBA. So then C complement is anything not in C, so A, B, AA, BB, okay? You get the picture, that's C complement. C star complement is really interesting, right? Because we have to think really hard. What's in C star, and then what's not in C star, right? So C star was like AB, AB. So certain things, like A is not, could not be in C star. A, B could not be in C star. There's no way for me to construct this from C star, okay? From C, from these kind of root strings in C. I never have a string that has AA in it to start off the string. I can't do that, okay? Same thing, B, B, A, A. I can't have this, I can't construct that from C by taking repeated concatenations. So therefore it's not in C star, therefore it's in the complement of C star. So again, we see here the complement of C star is anything that is in the universe that can't be in C star. Okay? So that shows us the star operation.